All right, everybody. Again, thanks for joining us. I think we'll get started about right now. So my name is Norman Ong. I'm a co-founder of Constantin Biosciences together with Nicholas Schaefer and Daniel Goldman. So you should be able to see all three of us on screen today. So Constantin Biosciences is a company that was founded back in 2020 with one mission, which is to accelerate clinical variant interpretation by leveraging MAVEs, or commonly called functional evidence, which you'll be hearing all about today. So in terms of today's webinar, it'll be about half an hour, and the format will be about a 15-minute presentation by Dr. Nicholas Schaefer, and then a 5-minute demo followed by Q&A at the end for about 10 minutes. Logistically speaking, we will be recording this webinar, as you could probably tell, and we will be sending out the recording of the webinar, within 24 hours after this webinar. So without further ado, I would like to introduce our speaker today, Dr. Nicholas Schaefer. So Dr. Schaefer has a PhD in physics with over 10 years of research experience, in computational biophysics. He actually has held a leading role in a company recently, leading a team of over 10 data scientists before joining Constantin full-time, the three of us. With that all being said, Nicholas, it's all yours.
Great, thanks, Norman, and thanks everybody again for joining today. So we're going to be talking today about MAVEvidence, which is our functional evidence platform for clinical variant interpretation. I wanted to start with this slide because if there's one takeaway that I want everybody to have, is that we're here for you to support you in your journey of applying functional evidence to variant interpretation. So today we're going to talk about some trends that we've identified and solutions that we've built. But if in the future you come across a question or a problem as it relates to using functional evidence for variant interpretation, whether it's related to the subjects that we discussed today or not, please reach out because we're happy to help. And on that note, I just want to talk a little bit about, if you were to reach out, who you're reaching out to. As Norman mentioned, I co-founded the company with two excellent scientists who, like myself, have a passion for translating basic research into the clinic. Daniel and I together have decades of research experience in protein biophysics, and our co-founder and MC for today, Norman, has been working for almost a decade on translating basic research into real commercial products that can help patients. And we spent the last 3 years really thinking about how to build tools that allow variant scientists to responsibly leverage data from biophysical assays in variant interpretation. And we've been very fortunate to be supported in those efforts by a tremendous team of advisors, which you can see on the screen. Fritz Roth, who's our founding scientific advisor, is a pioneer in the design and execution of high-throughput biophysical assays known as MAVEs. Vicky Parikh, likewise, our clinical advisor, is at the forefront of both basic MAVE research and is a practicing physician who's putting this type of data to work in the clinic. Our product advisor, Jean, has worked on the ground as a clinical genomic scientist and has worked as a product manager to integrate new technologies into variant interpretation workflows. And last but not least, Dr. Brian Schertz, who's our clinical consultant, is the author of multiple sets of recommendations for how to apply MAVE data to variant interpretation. So that's all just to say that this team is here to support you. And so if we can be helpful, please do reach out. These next few slides will likely not be a surprise to anyone here on the call, but variant interpretation is limited by available evidence, despite the fact that we have multiple lines of evidence that we can draw from to help classify variants. Population data sources like NOMAD and the UK Biobank have been critical in helping to interpret variants, but we know now that passively observing variants in the population is really a slow way to understand the impact of all possible variants. Furthermore, not seeing a variant in the population is not good evidence that the variant is pathogenic. Family segregation data can be one of the strongest sources of evidence, but it's really one of the hardest to collect, and it's hard to see how that's going to scale. When it comes to scaling, computational predictions have been getting a lot of press lately. But if you read enough to understand how those methods actually work, you'll see that at the bottom, these methods are inevitably based on some kind of experimental data or clinical data or both. So where do we really get new information about rare variants? The answer is functional data. And with recent technological breakthroughs, our ability to collect data on genetic variants is finally catching up with our ability to detect variants in patients. Functional data is the one source of data where we really have control over the scale at which we collect that data. And because of this, we believe that in the coming years, functional data will go from being a rare find for a variant scientist to the single largest source of data used to help classify variants. As another reminder, functional data already has a well-defined place in the 2015 ACMG-AMP guidelines. PS3 and BS3 codes can be used as strong evidence according to these guidelines, and subsequent elaborations on these guidelines have provided for grading the strength of evidence depending on statistical evaluations of the experimental data. And when we go to the demo later, you'll see that we're using the latest recommendations to provide calibrated functional evidence strengths within MAVEvidence. So I've mentioned the acronym MAVE several times already. MAVE stands for Multiplexed Assay of Variant Effect. And the main innovation here is the ability to measure the functional effects of thousands of variants in a single experiment. There are many ways to perform these types of experiments, but broadly speaking, they are performed as follows. You start with a population of cells and then prepare a library of variants. And here again, there are many ways to prepare the library of variants that have their own advantages and disadvantages, but lately, it's becoming more and more popular to directly edit the genome using some kind of CRISPR-based system. Once those library of variants have been introduced, a sorting or selection step is then performed, followed by one or more sequencing steps. And the raw data generated by these experiments is typically read counts of variants. And these read counts are then used to calculate a per variant function score. The assays are usually designed to include variants that have known clinical impact and those that do not. And the reason for that is that the subset of variants with the known clinical impact can then be used to determine how well the assay distinguishes between pathogenic and benign variants. And the subset of variants that do not yet have known clinical impact can then receive functional evidence to aid in their classification, along with other lines of evidence that are available for those variants. And these data have proven to be very impactful already in terms of resolving VUS. In this study, out of Ambry Genetics and the University of Washington, MAVE datasets from 3 genes were used to help resolve between 15 and 69% of clinically observed VUS in P10, BRCA1, and TP53. Furthermore, I mentioned previously that MAVEs can be used to study thousands of variants within a gene. However, very recent advances in gene editing technologies within the last few years have made it possible for these experiments to cover tens of thousands of variants across thousands of genes in a single experiment. And in this study, 52,000 ClinVar variants across 3,500 genes were characterized simultaneously. And we're aware of several large-scale efforts globally to cover the entire genome with functional data, starting with the most clinically relevant genes and variants. So we believe that over the next 5 to 10 years, there will be hundreds of experiments that generate functional data on millions of variants across thousands of genes, and all of this data will need to be considered when interpreting genetic variants. So these trends are, of course, both a major opportunity and a major challenge. New solutions are urgently needed to leverage MAVE data for VUS resolution. Without new solutions, variant scientists are bound to become overwhelmed by the rising VUS and the rapidly increasing amount of functional data. So those were all of the considerations that we had in mind when we designed our solution, which is MAVEvidence, the premier functional evidence platform for the clinical genetics community. MAVEvidence delivers greater than 90% time savings and 35% increased VUS resolution through comprehensive curation, rigorous analysis, and clear presentation of functional evidence. To illustrate how we do that, I'm first going to give a short demo of the platform and then talk about some of the benefits that MAVEvidence can deliver. So Norman or Dan, can you confirm you can see the MAVEvidence landing page?
Looks good.
Great, thanks. So this is the landing page of the MAVEvidence web application. And as you can see, the interface includes a gene selection. So you can see some of the genes that are available here, as well as a variant search box. In a minute, I'll load an example variant so that we can look at a report. The rest of the landing page provides a summary of the available data. Here I've selected BRCA1, and you can see that there's a schematic showing the exons and the coding region, as well as some relevant domains, and then 7 different high throughput MAVE assays that have been performed for BRCA1. And the blue bars correspond to the sequence schematic above, showing the region of the gene that was covered by this particular assay. If we go ahead and load an example variant, I can give me a second. I can show you what a report looks like. So behind the scenes, what's happening here is that all of the data for a particular variant is being collected into a single, easy to follow report. At the top of the report is shown the name of the gene and the variant that's being summarized. There's a sequence schematic showing where the variant is present in the sequence, and a summary showing an calibrated functional evidence code as an overall takeaway. With the high throughput nature of these assays, it's common to have multiple coverage for a variant. This variant happens to be covered 5 times by 4 of the 7 MAVE assays that were shown on the landing page. Each one of these pieces of data is then turned into a calibrated piece of functional evidence. In this case, 2 strong pieces of evidence, 1 supporting, 1 moderate, and 1 indeterminate. Overall, we're recommending BS3 strong for this particular variant. The rest of the report goes into detail about the data that was used to come up with this overall recommendation. It includes a gene level summary of the function of the gene, as well as evidence panels, 1 for each piece of evidence. So this report will contain 5 evidence panels. Each evidence panel contains the name of the assay, a link out directly to the publication where the data was taken from, a brief assay context explaining how the assay was performed, and 2 different versions of the so-called odds of pathogenicity, which indicates how likely the variant is to be pathogenic. One is a numerical representation, and the other has been translated according to published guidelines into a functional evidence code that can be directly applied within the ACMG AMP framework. The last piece of the evidence panel is the variant effect score histogram. This shows the scores of the known pathogenic and benign variants in red and blue, respectively. And then there's a dropped black vertical showing the score of this particular variant that we're looking at on this report. And so this provides an intuitive explanation as to why this particular variant is getting strong evidence in favor of a benign designation. What you can see is that overall, the assay does a good job of separating pathogenic and benign variants. And this particular variant has a score that is in the bulk of the benign distribution. As I mentioned, there's an evidence panel for each piece of data showing the different assays in that same representation. And what you can see by looking at the different assays is that the assays have different strength in their ability to distinguish between pathogenic and benign variants. This assay in particular for this variant gives indeterminate evidence, as there's significant overlap between the pathogenic and benign distributions, and also the score for the variant is near to the middle of the score distribution. The last piece of the report is a notes and references section, which explains how the data was curated, how it was analyzed, and provides more links out to references. With that, let me start the presentation again. Well, MAVEvidence, as I mentioned, is designed to harness the power of MAVEs and seamlessly integrate with your workflows. We are actively curating the literature to ensure that we stay up to date with all of the latest studies. As you see, we provide a variant level search through both a web application and an API. We follow published guidelines to systematically turn the data into evidence so that it can be directly applied within your workflows. And we provide an easy to follow report that summarizes the available evidence so that you can analyze it for yourself. For organizations that have their own internal platforms, we support API integrations into your platform so that you don't need to use yet another application. And all of this comes with timely support from our team. In addition to being comprehensive and full-featured, MAVEvidence is a trusted and proven resource. And we were selected in a competitive process by the NIH as one of the companies that's most likely to have a major clinical impact. And we've demonstrated the ability to rapidly integrate data into MAVEvidence so that we stay up to date with the literature, with updates being released on a regular basis. And based on 2 large-scale studies with potential customers, we've demonstrated the ability to resolve between 32 and 38% of US where the data is available within MAVEvidence. And based on interviews with more than 100 stakeholders across the industry, we've estimated that we can save more than 90% of the time that it would otherwise take to leverage MAVE data for variant interpretation. With that, I think it's about time to wrap up the presentation portion. I just wanted to say that MAVEvidence is live and you're able to try it now for free. If you go to the link that's shown in the bottom there, all you need to do is click sign up, fill out a few fields, and you're able to start using it today. So with that, I think we'll turn to the question and answer portion.
Great, thank you so much, Nick. So let me see, in terms of questions from the audience, maybe I should start off with one question of mine. So Nick, how do we know if an assay is good enough to use for variant interpretation?
Yeah, this is a critical question. So maybe I can try to go back here. As I mentioned, the original guidelines used a somewhat ambiguous term, well-established functional study, and subsequent guidelines have elaborated it to allow for graded calibration of functional evidence. And so different organizations will take different approaches towards this. Our philosophy leans towards the inclusion of data, but with rigorous statistical evaluation. And so as you saw on the report, there were several different assays that had different strengths, and we choose to include all of the data, but then provide a rigorous statistical evaluation to show, provide the appropriate level of strength of evidence depending on the assay and the variant effect score.
Great, thanks for the detailed explanation. Another question that we're getting is, does MAVEvidence include any sort of splicing information?
Great question. So for the time being, MAVEvidence is focused on coding variants. And so the assays take different approaches. And as I mentioned, one popular increasingly popular type of assay is a CRISPR-based genome editing experiment, which do have the possibility of capturing splicing effects. So there would be a readout that could capture splicing effects for those assays, and those are noted in the assay context part of the report. But if you went looking specifically for non-coding variants, right now, MAVEvidence does not include the non-coding variants, including the splicing variants.
Thanks, Nick. Yeah, so the other question is, how do you determine that an assay is considered high throughput? Yeah, how do you do that?
Yeah, so here again, this is something that's evolving. There's not a clean definition necessarily of what's considered high throughput. What's canonically considered a MAVE will include data on thousands of variants. However, there are very valuable data sets, especially those that were designed specifically to capture enough reference variants, where hundreds of variants can be sufficient to really calibrate the strength of evidence well. And so the approach we've taken is to start with the highest throughput assays and ensure that we have those available within the system, and then continue to improve our automation so that we can include both our automation and our statistical evaluation methods so that we can include lower and lower number of variant assays as time goes by. And I think in practice, what that means now is that if we see an assay that covers 100 variants and with a sufficient number of reference variants to do the calibration, then we'll go ahead and include it. So we're not being dogmatic when it comes to inclusion of assays.
Great. So that's another question from the audience. So if we have carried out a MAVES, how do we get the data from our study available on MAVEvidence? Is it automatic, or does it draw from like another database such as MAVEDB, or are we able to upload the data ourselves? Probably more like more like CleanVar. Sorry.
Yeah, that's great. It's great to hear this question coming. So I guess the first thing to do would be definitely reach out to us. In terms of to answer the question, as I mentioned, we actively curate the literature, so we're constantly looking for new assays as they get published. And so it's very likely that if you did publish your data, again, barring any restrictions around the license, that it would appear inside of MAVEvidence. And certainly if you have published data and it's not appearing there and there's no restrictions on the license, then just by all means reach out to us. Even if you haven't published the data yourself, but you see a high throughput assay that you'd like to appear in MAVEvidence, reach out to us. So I guess that's the answer, is that we're happy to hear from anyone who's involved in the generation of the data, all the way through to the application of the data in the clinic.
Yeah, that's great. Yeah, feel free to reach out to us. We'll be very happy to talk to you. And then one more question is around, what is Constantium's plan to scale up the platform? Has there been any sort of, I guess, has there been any effort to, be able to quickly integrate any sort of new MAVE data that are available?
Absolutely. We see it as a key responsibility to be able to keep up with the literature. And this has multiple facets, I would say. One is simply improving our automation systems so that, once data is released, it can be rapidly evaluated. But also, allowing us to move, to push the boundaries in terms of what can be responsibly included. And so in addition to improving our automation, we're constantly improving our statistical evaluation methods. And so that if an assay has, say, a relatively small number of reference variants, how can we, do a good calibration so that that data can be available there for the data scientists or for the variant scientists to include in their review, without necessarily having a very large number of reference variants. And so, in summary, we are constantly improving, our ability to monitor literature, to integrate data sets once they're published, and to responsibly evaluate those assays, regardless of the number of variants and reference variants that have been included in those assays.
Wonderful. Another question from the audience. Is all the data in MAVEvidence published already? So, yeah, maybe I'm not getting the question correctly, but
yeah, I think I understand. So again, if you did a search and you found data for a variant, it will provide a link out to the publication, and so there will be some sort of publication associated with the data at this point. It may be a preprint, or it may be something that has gone through peer review, and that will be clear, based on the link that's provided in the report. And we do try to anticipate data sets that have come out, but there, as of now, there's nothing in the platform that hasn't been published in some form.
good answer, Nick. Thank you. Maybe one last question. I think we're getting close to the half-an-hour mark. So do you include any sort of synonymous variant information on the platform with the analysis that you guys do?
Yes. So I didn't, thank you for whoever asked that question. I didn't point it out while we were on the report, but again, if you go to a report, what you'll see is that the variants that are used to do the statistical calibration of evidence are designated pathogenic and benign variants. However, we also include on that variant effect score histogram any nonsense and synonymous variants that were measured in the experiment. And so while those aren't directly used in the calibration, they are included there on the variant effect score histogram. And especially for assays where there are a small number of reference variants available, those sort of proxy reference variants can be helpful with context about the mechanism of action of the the variants in those genes. And so yes, where available, we include those scores, and you can see them on the variant effect score histogram along with the pathogenic and benign variants, as well as the nonsense variants.
All right, looks like we have time for maybe one question, and that is, do you include data from research institutions or tests that you are developing in-house?
Yeah, so as we mentioned earlier, all of the data has been published into the literature at this point, and so we're definitely including data from research institutions around the world.
Great, perfect. So I think that is all the questions that we have time for today. So I just want to thank everybody for joining. And obviously, I want to thank Nick as well for the great presentation. Yeah, we will be sending a follow-up with a video recording of this webinar. But if any of you have any follow-up questions, obviously feel free to reach out to us. You can go to our website and fill out the contact form, or I believe our email is inquiry@constantinebio.com. But obviously, we would be delighted if you would try out MAVEvidence platform. All you need to go is, as you can see on this slide, just go to MAVEvidence.com, and the sign-up process takes less than a minute, and you can pretty much start using right away. If you have any questions after that, let us know. But again, thank you, everybody, and maybe happy early Thanksgiving to everybody who's celebrating in the US. And again, thank you so much.
Yeah, thanks, everybody.